I'm doing my I'm doing my 6-minute talk on magnetic levitation. And the reason I chose this topic is because about a year ago, I was on a design team with a couple of other mechanical engineering undergrads called Hyperloop. We had to build this huge pod that would be tested in as close to vacuum as possible. And like the feasibility of Hyperloop is is a whole different discussion for another day. But one of the things we use to create the lift to get it off the ground is magnetic levitation. And it's just a cool technology. So what is magnetic levitation? Magnetic levitation, simply put, is just the suspension of an object through the sole use of magnetic force. And this is achieved through these two principles known as Faraday's law and Lenz's law. We all have taken Physics 2113. We all kind of remember those from that class. But essentially what those state is that if you take a magnetic field and move it over a conducting surface, or vice versa, if you take an electric current and move it over a magnetic field, essentially there's going to be two magnetic forces that create opposition that cause the lift. I know that's kind of a lot and kind of weird when put this way, so using copper as an example, since that is a conductive surface, you can say a magnet like a neodymium iron boron magnet or some sort is accelerated over a copper or aluminum surface. We use aluminum for when we run Hyperloop. And what that does is it creates a current inside the copper surface. And that does a couple of things. It generates heat within the copper or whatever surface you are using. But generally it dissipates very, very quickly. So the efficiency, or not the efficiency, you don't really get too much energy loss from the heat generated. But what the big thing it does is the current creates an opposing magnetic field, which then causes the lift. And this is used in a whole bunch of different applications. We've all heard of maglev trains. They're really big in Europe and Japan and other countries like that. And they basically use that principle of, in an interesting way though, rather than using permanent magnets like the neodymium iron boron, they use coils. And as you can see, there's coils in the track and on the train in this little wraparound section. And they work in a very interesting way because they're able to create both propulsion and levitation through the use of those concepts, those laws. They alternate the current going into each of those coils, which creates propulsion down the track. But I mean, what everybody wants is a hoverboard. That's what everybody wants. I mean, they were popularized with Back to the Future, but unfortunately those don't work using magnets, those work using movie magic. But this company known as Archpax, which is where we got our hover engines when I was on Hyperloop, uses this system right here, which I'll talk about a little bit. And it uses Faraday's and Lenz's law, just like the maglev train does. But unlike the maglev train, rather than using coils in the track and in the train itself, they take permanent magnets and spin them at very high velocities to create this lift. And there can be propulsion created using these engines through the angle, the normal angle that it creates with the surface. Just an interesting side note about the construction of these engines. So, like I said, they use permanent magnets to create this lift. But one little interesting thing I really like is that rather than just having all the poles going the same direction with each magnet, because it's an array of magnets, they use this thing which is known as a Halbach array. And it has this really interesting effect where it eliminates the magnetic field on one side of the array, but it dramatically increases the magnetic field on the other side of the array. So you're able to get not only are you able to be more directional with how you use the engine, but you're also able to get a lot more force with a lot less. And which I'll talk about in a bit, but one big downside of these technologies is that they can be very, very expensive. And I mean, we're all studying engineers, like cost is probably the biggest thing beside the actual thing that you're trying to build most of the time. So you got to be very careful whenever you're choosing these things. And I think this is a great way of cutting down the cost while using these same principles. Yeah, and I pretty much just went over all of it. I'm out of time, so I'm just going to go ahead and stop there.